Welcome, my friends. A common way to express the equation of a line is in what is called slope-intercept form, y equals mx plus b. M is the slope and is a measurement of the steepness of the line. B is the y-intercept and indicates where the line intersects the y-axis. This equation is called slope-intercept form as it is very easy to identify the slope m and y-intercept b from the equation. For example, in the line y equals 2x plus 4, the slope is m equals 2, and the y-intercept is b equals 4. The graph of this line looks like this. The slope is 2, meaning if we move 2 units up from our line, we must move 1 unit to the right to be back on the line. The y-intercept is 4, indicating that the line crosses the y-axis at y equals 4. There is another common way to express the equation of a line in what is called standard form. ax plus by is equal to c. For example, consider 3x plus 8y is equal to negative 2. Let's say you were asked to find the slope and y-intercept of this line. The easiest way to solve this problem would be to convert the equation into slope-intercept form. In other words, solve the equation for y. First, we would subtract 3x from both sides, which would leave us with 8y is equal to negative 3x minus 2. Then we would divide all three terms by 8, leaving us with y equals negative 3/8 x minus 2 over 8. Our constant of negative 2 over 8 can be reduced to negative 1 over 4. From here, we can easily identify that the slope is equal to negative 3 over 8, and the y-intercept is equal to negative 1 over 4. If two lines have the same slope but different y-intercepts, they are said to be parallel lines. For example, y equals 2x plus 3 and y equals 2x plus 1 both have a slope of 2, but have different y-intercepts. If we were to graph these two equations, they would be parallel to each other, meaning the lines will never intersect. Another interesting case is the set of perpendicular lines. Perpendicular lines intersect at a right angle, as can be seen from the graph. The equations of the two lines are y equals negative 1/2 x plus 2 and y equals 2x plus 1. The relationship that the equation of perpendicular lines have is that their slopes are negative reciprocals of each other. That's just a fancy way of saying flip the fraction on your slope and make it negative. For example, the slope of 2 from y equals 2x plus 1 could be written as the fraction 2 over 1. The reciprocal of 2 over 1 is 1 over 2, or 1/2. The negative reciprocal of 2, or 2 over 1, is negative 1 over 2. Therefore, the slope of a line perpendicular to the line with a slope of 2 will have a slope of negative 1/2, as we saw with the equation y equals negative 1/2 x plus 2. Let's try another example. Consider the line y equals 1/5 x plus 4. What would be the slope of a line parallel to this one? What about a line perpendicular to this one? Well, parallel lines have the same slope, so a line parallel to this one will also have a slope of 1/5. Perpendicular lines have slopes that are negative reciprocals of each other. The negative reciprocal of 1/5 is negative 5 over 1, or simply negative 5. So a line perpendicular to the one given here will have a slope of negative 5. You could be asked to find the slope of a line parallel or perpendicular to a line expressed in standard form, such as this one here. Negative 5x minus 7y is equal to 3. The first step will be to find the slope of the given line, and the easiest way to do that is to convert this equation into slope-intercept form. Adding 5x to both sides, we get negative 7y is equal to 5x plus 3. Dividing by negative 7, we get y is equal to 5 over negative 7x plus 3 over negative 7. This can be written as y is equal to negative 5 over 7x minus 3 over 7. The slope of this line is negative 5 over 7, and therefore a line parallel to this one will also have a slope of negative 5 over 7. The negative reciprocal of negative 5 over 7 is positive 7 over 5, and therefore a line perpendicular to this one will have a slope of 7 over 5. Okay, here's one for you to try. Given the three equations, determine which sets of lines are parallel, which are perpendicular, and which are neither parallel nor perpendicular. Pause the video and give it a shot. Alright, hopefully your first step was to convert the equations of 1 and 3 into slope-intercept form by solving for y. I'm going to skip the algebra here, but you should try it out if you haven't done so already. Solving the first equation for y, we get y is equal to negative 5 halves x minus 2. The second equation is already in slope-intercept form, so I'll just rewrite it here. Solving the last equation for y, we get y is equal to 2/5 x plus 6 over 5. Now let's identify the slopes. The slope of line 1 is negative 5 over 2. The slope of line 2 is 2 over 5, and the slope of line 3 is 2 over 5 as well. The first thing that jumps out to me here is that lines 2 and 3 both have a slope of 2 over 5. We know that lines with the same slope are parallel, and therefore lines 2 and 3 must be parallel. I also notice that the slope of line 1 is the negative reciprocal of 2/5, negative 5 halves. Perpendicular lines have a negative reciprocal slope, and therefore line 1 must be perpendicular to both lines 2 and line 3. Alright my friends, that completes our video covering the slope of parallel and perpendicular lines.